Lifting, chunks of air are lifting. Condensation means that's when you're going to get the clouds, because clouds are water that is condensed, and level just means like elevation. All right. So I'm going to kind of talk you through two scenarios. One is where at upper elevations it's really cold, and the other is it's just kind of cold. We're going to go ahead and call it warm. I bet you well, how do I say this? By the way, precipitation, I think I mentioned before, is water dumping from the atmosphere to the Earth's surface. And that's why I have a little bit of issue with fog being precipitation. I'm sure they know more than I do. Bergeron, I just like the word. And a lot of times when I talk about meteorology, Bergeron will make it as one of my vocab words. And it's more complicated than I'm going to go into. But Bergeron process just means like the forming of snow, forming of ice crystals, I guess more specifically at upper elevation. Forming of ice crystals. Okay. So this is just one little figure to kind of show you what the Bergeron process might look like. You see the infamous or the famous water molecules with the red oxygen atom and the two hydrogen atoms that look like Mickey Mouse molecules. And then here we see the Bergeron process is the creation of ice crystals, and this is actually kind of molecule by molecule the formation of a beautiful little ice crystal up here. These here, right here, the blue orbs are actually liquid water. So you're like, well, how can we have liquid water and ice crystals at the same time? Well, it's kind of a long story, but if you take another class in weather, they'll talk about this is actually super cooled water, which this liquid water is cooled at a temperature well below 32 degrees Fahrenheit. What I started to say a minute ago was like when we have rain events, oftentimes those rain events start out as snow. So we're going to talk about kind of layers of the Earth's atmosphere probably next week. But one of the things about, here's the Earth's surface, one of the things about the Earth's atmosphere is we can kind of break it up into four main layers. Okay, and these layers get thicker and thicker, so they're not drawn to scale. But this layer is called the sphere, okay, this layer of air above the Earth. And actually it contains pretty much all of our weather. Pretty much all of our weather. And so the deal is within the troposphere, as you go up, it gets colder. It just does. You might say, well, that's a way we can go ahead and get clouds to condense. Well, sort of, but more of it's the increase in size and the cooling effect. But here's the deal then. I'm going to go ahead and draw a cloud. Okay, here's my cloud. So this this little thing hopefully looks like a snowflake. Okay, and can you see where if it gets colder as you go up, it's warmer down here. So all I'm saying is at some point it reaches the point where it melts. By it, I mean the snowflakes melt. And then if this is it, then we go ahead and we have, these are my raindrops. And this is us down here. Okay? So a lot of times it starts out as snow and ends up as rain. But here's where I get to kind of talk you through a couple of different scenarios having to do with the temperature. I'm not going to try to draw the temperatures up here. I have them actually on figures. So this is what I drew first. What did I draw? I said, well, it's cold up here, okay, and it's warmer down here, okay. We've got 14 degrees Fahrenheit up here with the cloud. We've got 59 degrees Fahrenheit down here. Like, okay, so I know that it's not going to be solid because it freezes at 32. This is normal. Then we have this scenario. And I like these slides because they are like color-coded. So the blue means that it's cold enough for water to stay solid state. And the pink or the red means that water should be a liquid then. So this is when we get snow. Seems reasonable. we have recently had some situations where we have freezing rain. And I'm going to show you what that looks like. In order for freezing rain to occur, basically, it's not that complicated. I don't know if I have another color up here. I guess I do. I've kind of run out of room. But what if we go ahead, our ice melts. We have ice up here, our ice melts. And what if we have cold air, a pocket of cold air here, which again is not usually what happens in the troposphere, but it can happen. A pocket of cold air can sneak in here. Then what can happen is this liquid now is going to refreeze here. Okay, and this, what I've kind of shown you, is what we call a temperature inversion. So this is a temperature inversion where we have blue, pink, blue. Again, blue means that it's colder than cold enough or colder that for water to be solid. Okay, pink means that water's going to be a liquid. So we have solid, liquid, solid. That's it. Now, depending upon how deep this pocket of cold air is, we will either get freezing rain or sleet. Here's the deal: if it's pretty narrow, it doesn't have time to pelletize. Pelletize? Okay. If it's nice and deep, which this one kind of looks deep, it's got enough time to go ahead, and it's not going to freeze into cute little snowflakes, because that's the Bergeron process, and that takes a little bit of art up there. But it's going to freeze into little pellets and hit you on the head. Okay, it's going to be sleet. We will get to hail, and I kind of say that softly because hail is different than sleet. It's totally different. It's like, well, we're both little ice pellets, and yeah. Okay, so that's freezing rain and sleet. Oh yeah, I guess I did have two slides. So the glaze here is the same thing as what I would call freezing rain. Notice that the pocket of cold air is a lot more shallow here than it is over there. So you might hear meteorologists talk about a temperature inversion, and that's actually what can give you freezing rain or sleet. The word inversion just kind of means backwards, upside down. Well, it's possible that as this, it's warm enough up here so we don't have the Bergeron process, we just have cute little water droplets. I'm going to kind of talk you through that. But those aerosols that we saw in that little catchy video a minute ago, those aerosols are generally called cloud condensation, CCN. They help get the party started. They help let the water vapor go ahead and condense into a liquid or go ahead and start the Bergeron process. So here we go. This is a warm cloud, so no ice crystals forming here. We have an assortment of these little droplets are liquid, okay? But you have to picture between these liquid particles here, we've also got an assortment of water vapor, just itching to go ahead and join the party, okay? And the video we watched kind of talked about when they get large enough, they will fall from the cloud. It's called the collision coalescence process. And it just means that these particles will collide with each other. Let's see, the bigger they are, the more quickly they're falling. And we have these like collector droplets kind of gobbling up little ones. Bigger, bigger. And this is just kind of showing you that kind of in order. C is showing you how big that collector droplet is. And you figure it's you kind of see the motion by the little wisps up there. And it kind of, I've seen animations where it starts to kind of get wobbly and actually can break apart. And we get now, instead of one humongous collector droplet to fall and to kind of collect and coalesce with the little droplets, now we've got 5. And the process continues. Okay. So, one of the things I know you'll see on your Unit 2 exam in here is probably a sketch, and you'll have to go ahead and tell me which cloud is which. The sketch may or may not look like the next slide. Probably look kind of like the next slide. So how do you give names to these clouds? Well, we kind of mix and match two things. One is what we call their form. And you've seen these before. I know you have. If they're nice and flat, which actually I think today we've got nice and flat ones. We actually call that a stratus type. And if they're fluffy, like this one, we call that a cumulus type. okay, cumulo or cumulus. Then the other thing, the other criteria is how high above the Earth's surface are they? What's their elevation, generally speaking? So we have three possibilities. We have low clouds, okay, and they have no prefix. Prefix means kind of in the front of the word. We have middle clouds, and they have the prefix alto. And then we have high clouds, and they have some sort of prefix, cirrus or cirro. Okay? So we mix and match this with low, mid, high. And you're like, sometimes you're like, well, how would I know? Well, there is a little bit of a guideline, but you just kind of guess. This is no prefix, this is alto prefix, and this is cirro, cirrus. All right. Now, I guess there is a third criteria. This is my second criteria. This is my first criteria. The last criteria, I guess, is it precipitating or not? And we use nimbo or nimbus. Is it precipitating? So we mix and match these three criteria. Raining, if it is, then you go nimbo / nimbus. All right, so let's see what that looks like. So here we go. I know it's hard to see, but there actually are 10 cloud types, and the type is, the words are kind of small. If you actually Google cloud types, 10 cloud types, you'll get all sorts of pictures. You don't like this. So let's start with the high clouds. High clouds. Okay, so you can actually see in this figure, I have low, middle, high. High clouds up here. I said they're going to be cirro or cirrus. Okay. Notice we have high flat ones, cirrostratus. We have high fluffy ones, cirrocumulus, and sometimes the cirrocumulus are called, say, mackerel skies, kind of like fish scales, like fish mackerel. And then we have the real high wispy ones. They look like what's called mare's tails, cirrus. Okay, so there's three high clouds. Then we have the middle clouds, and if they're middle, we're going to use the word alto somewhere in their name. So I just have a couple of middle ones. I have alto stratus, that means middle flat, and alto cumulus. So here's the deal. They say, how could you tell between an alto cumulus and and a cirrocumulus? Cirro meaning high, alto meaning middle. Well, the cirrocumulus is about the size, is this right? Yeah. If you extend your hand, the fluffs are about the size, altocumulus, the middle one. Altocumulus about the size of your thumb, cirrocumulus about the size of your pinky. All right, then we have the low ones. The low ones, again, we don't do alto or cirrostratus, we just go what the cloud is. Let's start with the easy one. So if it's just stratus, it means, since it doesn't say alto or cirro, it must be low. So it's flat. So low flat. If it just says cumulus, doesn't say alto or cirro, then it must be a low cumulus. Okay? If you're just playing with cumulus. This one right here is one of my least favorite sort of cloud, and I think we see them a lot here in the Midwest. Stratocumulus. You're like, are you serious? That's like the two options in one category. Don't blame me. It just is. It's a type of cloud. Well, stratocumulus, it must mean that it's got some sort of layering or flatness and some sort of fluffiness in here, right? All right, what did we not do? Oh, yeah. So here we go. Nimbostratus. Nimbo, one of our two types of rain clouds. Stratus meaning flat. Nimbostratus clouds are usually kind of low-level clouds. What don't we have? Well, we don't have the other nimbus cloud, cumulonimbus. Now, cumulonimbus clouds are thunderstorm clouds, basically. Cumulo meaning fluffy, nimbus meaning precipitating. So these are the ones, actually, they don't have a specific elevation. To me, those are, like this says, it has a great vertical development, okay? And that's actually related to the instability of the air forming that cloud. So down here we see the storm cloud and all that. So let's look at some pictures. Okay, so the cirrus cloud Actually, this looks like a cirrocumulus cloud. This is the macro sky. That's the size of your pinky. You can't, this is actually, if we had more time, we'd kind of talk about cool optical phenomenon that are caused by clouds. If you have high wispy clouds, they have these awesome ice crystals that can make the sunlight do cool things. And this is looking at a halo around the sun. Cirrostratus, so cirro meaning high, stratus meaning flat. Cirrocumulus, cirro meaning high, cumulus meaning fluffy. So this is an altostratus. It's got some color to it. It must be kind of when the sun is low on the horizon. Alto meaning middle, stratus meaning flat, altocumulus, alto meaning middle, cumulus meaning fluffy. These are about the size of your thumb. Low clouds, stratus, cumulus. And notice, and they have these kind of cool little 2 letters that go along with the name. This is stratocumulus, one that drives me nuts. And precipitating clouds, we have kind of the flat, relatively low nimbostratus. We get these in the wintertime a lot. And then we can have these thunderstorm clouds, where we have what we call vertical development with the cloud. Cumulonimbus. Okay. So, types of fog. So, based upon kind of what we've been talking about, you figure fog is kind of a very low level cloud, and you'd be right. Very low level clouds. And there are, in order to get a cloud to form down here at low elevations, we need to do one of 2 things. We need to, or both of them, we need to cool down the air and or we need to add water vapor. So there's 4 different ways we can generally do that. Here's one for you, radiation fog. And radiation fog the word radiation is kind of referring to the fact that, I'm going to erase this because it's, at nighttime, the Earth's surface cools off, and we call that just kind of, it's re-radiating the energy it got from the sun during the day. So here's my surface. It's nighttime. By the way, Saturday's supposed to be clear. I'm hoping to get some scope time. See if you can see the moon on Saturday. So during the daytime, this gets hot, and at nighttime, it's cooling off. That's my radiation cooling off. What happens with radiation fog is it basically cools off to the point of this is all up here now. And this is, it's done cooling, okay? So it's cool enough to go ahead and have fog form overnight. Advection fog has to do with kind of taking warm, moist air in over a cold surface, and then then it reaches the point where air condenses within that chunk of air. Upslope fog is kind of like the fog kind of like slamming air against a mountain, kind of what we call orographic lifting. It's kind of similar to upslope fog. You know what I mean? Upslope fog. Evaporation fog is actually what happens in your bathrooms in the morning sometimes. Evaporation fog in your bathrooms are all about, like if this is my shower head, okay, this is my liquid water coming out of my shower head. Well, some of that liquid is going ahead and going from a liquid into a gas. So water vapor. So I've got now these water vapor particles in my bathroom that didn't used to be there. And what does water do? If it gets cold enough and or high enough concentration, water vapor, it's going to go ahead and condense. Okay, so that's how you can steam up your bathrooms. Okay, I was going to go look at clouds, but I don't think there's much to look at. Instead, what if all teachers are like, oh my gosh, we're going to know another snow day, so let's get some material into people. That's how I am. Oh my gosh. So, here we go. Another important concept in understanding how the whole weather thing is working around us. Let's see if this works. Ooh, that's a good sign. Okie dokie. So air masses, and a lot of times people, I didn't bring in my earth, but a lot of times people have a sense for it's cold at the poles, right? And it's hot near the equator. Well, what if you have a chunk of air that hung out over the poles, polar vortex, and then ended up kind of moving down towards the equator? That's kind of the concept of an air mass, okay? A chunk of air about the size of a large state will hang out at a spot and pick up the characteristics of that spot. They call it kind of like an accent. Like if you go down south, you might pick up a southern accent, okay? It's important though that it dwells there for a while, that it remains stagnant. So the place where it sits, by the way, I think I have the word in there, is called the source region for that air mass. So some places don't make good source regions just because air can't hang out long enough to pick up the accents, okay? So there's the word source region. So source region is just the place on Earth where that chunk of air sits for a couple weeks, okay? Now the two things you're going to see that we care about a chunk of air, characteristics of an air mass, there are only two things instead of three. The two things you care about an air mass are its temperature and its moisture content. Okay, so with regard to moisture content, if you have a chunk of air sitting over a land mass, it's going to be pretty dry. And we're going to actually use the lowercase. Now you do need to know these symbols, like these little letters, unlike the letters that go with the different 10 cloud types. So you're going to know a lowercase c talking about an air mass. C means continental. In your own mind, you need to translate that to dry. Well, if you have a chunk of air that hangs out over an ocean, we do have chunks of air that hang out over an ocean. And it's kind of fun to think of them just sitting there for a couple weeks. Then they get on the move and they bring their moisture over land and they can dump. Okay, so anyway, we would use the letter, the M, for that, associated with that type of air mass, and the M stands for moist. Moist or maritime. You'll see me kind of go back and forth. Temperature-wise, we have three options. You guys would probably say tropical sounds hot, and you're right. We use a capital T. Actually, use capitals for the temperature part, and we use lower cases for the moisture part. The other option, I know it sounds cold, but it's not as cold as the third option. Polar, capital P, it's cold. And you've probably heard this recently, Arctic air mass, right? Capital A for Arctic. That just means it's bitterly cold. So cold and bitterly cold. And I've got family down in Mississippi, and they think it's all bitterly cold. I'm like, no. Okay, so we kind of mix and match these variables, but these two go away. So you have to pick one of these two, and you have to pick one of these two. One of these three, excuse me. All right. So our source region will have a specific moisture and a specific temperature. And we end up with 6 air mass types. Some would say 5, but 6 air mass types. So just like I said, there's a good chance your next unit exam is going to have a figure of clouds, and you need to tell me which cloud is which. So also probably your next unit exam here is going to have a picture of the map of the United States, and you have to kind of tell me where it makes sense that you're going to get. If you have a chunk of air hanging out there, is it going to be a dry or moist, C or M, or is it going to be tropical, polar, or Arctic? Okay, so, and they make sense. I like this. So maritime, tropical, here are our source regions. So we just mean a chunk of air needs to sit over here. Of course, this is your Pacific Ocean, and this is your Atlantic Ocean. Okay. After they sit there for a while, if they move this, they're moist and they're warm. Well, source regions for continental dry air mass would look like this. So continental, meaning it's going to be dry, it's over continent, and tropical, meaning it's warm. Now the asterisk here actually goes down here. Asterisk says our continental tropical air mass will only form in the summertime. That's the only time we'll get those. This time of year, we don't get continental tropical air masses in our hemisphere. All right. Maritime polar, maritime meaning moist, polar meaning cold. So where are we going to get those? Well, again, since they're moist, maritime, we're going to get them off the ocean. So we got one on our west coast, one on our east coast. Makes sense. And then we have continental polar. Continental meaning it's going to be dry, polar meaning it's cold. So we got the whole Canadian, we get those from Canada. And then the last one I have here is, I have two more. Maritime Arctic. Maritime meaning it must be over a large body of water. We're looking here at the Pacific Ocean. And Arctic meaning it's actually even closer to the pole than our polar. And then the last one, that over Greenland, continental Arctic. So continental means over, it's dry, relatively dry, although all very bitterly cold air is going to be relatively dry, but continental Arctic. So there you go. So it might not be the same figure, but something like that. When we talked about the 4 ways of getting a chunk of air to lift to a chunk of air to rise and expand and get to the lifting condensation level so it can form a cloud, we said one of the ways is actually frontal lifting. We're going to talk about fronts here. All front is you have chunk A, chunk air mass A, and chunk air mass B, and where they collide, that's the weather front. Okay, that's it. We're like armies. And oftentimes where you have these 2 air masses that meet right along that boundary, we call a front, that's where you're going to get your interesting weather. I know a lot of people are into like chasing storms, such like that. Yeah, storm chasers. And in the summertime, that's where you are going to be looking probably along your fronts. So you've probably seen these fronts on a weather map before. I'm going to talk you through the 4 types of weather fronts. The first 2 are a little more straightforward. Actually, the first 3 are pretty darn straightforward. The 4th one's a little weird. So what I like is even if you're colorblind, well, I should say, warm fronts are usually red. I'm going to put the word red down here. They're usually red. But on this black and white version, it's just going to be semicircles. And whether it's a warm front or a cold front, the direction of the direction of the line, the side of the line that the semicircles are on are showing you the direction that it's moving. So I could do an arrow down here. I could say this chunk of warm air is moving this way. Warm front means you have warm air on the move. Warm air mass. It could be continental or it could be maritime, but that creates your warm air on the move. And again, the direction of the line where the semicircles are not on, I guess you could say, is where it's coming from. So the cold front is usually blue. And again, the fact that I have triangles over here on the top of it means that I must have cold air mass pushing up from the bottom. Oops, go back. All right, so those are kind of, now actually, this is kind of weird. Here in the Northern Hemisphere, we usually have our cold air is usually pushing down from the north, so it's kind of weird how it's oriented. Then there's this one. This one is a standoff. It's like, you're like, dude, I have the triangles, which means cold air, I have the semicircles, which means warm air, cold, warm, cold. You're like, what? And usually it is actually alternating blue, red, blue, red, blue, red. And it just means that, the word stationary says it all. Basically, your two air masses, nothing's giving, nothing's moving, okay? But I can tell the way this is oriented that since I have semicircles down here, that must mean that I have, let's see, warm air up here. And since I have triangles over here, triangles at the top there, I must have cold air. See here, see how that works. The last one, and actually I'm going to go ahead and I have a slide to try to explain this. You can see the difference between the stationary front and occluded front. In the occluded front, we have actually the triangles and the semicircles alternating on the same side. And usually, I think like my site says, usually these are purple. Okay, so I'll talk about an occluded front here in a minute. But when you have two chunks of air meeting, making what we call a front, that front can have kind of different characteristics, somewhat depending upon how much one chunk of air is there going to be a slope or not. Now, I would call this transition zone, this front between this cold air and this warm air, I would call it pretty much straight up and down, pretty much vertical, not much slope. Now, the fact that they're kind of showing the cold air being the aggressor, okay, cold air is more dense, and actually, cold air dense, and it reminds me we've definitely seen our fair share of the snow shovels, like the trucks, when they're going to clear the roads. That scooping sort of reminds me of what cold air does. And so actually what you're looking at here is, this is a cumulonimbus cloud. If we compare that to, this is actually a warm front, like the slide says, it's a cold front, and where the warm air is being aggressive, the cold air is dense, and so the warm air is aggressive and all that, but it has to go up and over the cold air. And so you kind of get a series of clouds in front of the precipitation, which probably will be more like nimbostratus than cumulonimbus. Types of precipitation differ with the fronts. Overrunning is actually this right here. This is overrunning, where it kind of goes up and over. And you kind of get these clouds in advance of the precipitation. Oops, sorry. And this precipitation right here, this is a storm cloud. It is very abrupt. And this right here, this gentle is it can be long lasting, gentle sort of precip. So what's that weird sort of occluded front? Well, an occluded front makes use of the fact that cold air goes faster and literally will move along the ground faster than warm air. So with an occluded front, we actually end up with three chunks of air: chunk of air A, chunk of air B, and chunk of air C. And I don't know how you want to think of it. If we call this chunk of air A, chunk of air B, chunk of air C, basically the cold air catches, cold air is moving so fast that it kind of lifts the chunk of air up that was between, we call this A and C. B kind of gets lifted up because A is so fast. That's it. That's an occluded front. Occluded fronts, remember, on the weather map are alternating triangles, semicircles, triangles, semicircles on the same side of the line. And the weather you get with occluded front is similar to what you get with a cold front. All right, so here's a weather map, kind of a mixed weather map. And you can see the triangles up here. So this would be our cold front, okay? The semicircles here, this would be your warm front. And we're talking more about these L's. Of course, L's, well, not of course, but L, that's what we call central low pressure. This H right here, that's a central high pressure. We'll be talking more about that, pressures and stuff. But very kind of your typical sort of weather map. So go ahead and jot these down. So these will be due. Did you have them at the end of the last part? Is there an assignment at the end of part 1? Oh, there you go. So this assignment at the end of part 2. That works for me. I am behind in my readings. That really works for me. Before you go, I'm going to let you jot that down. Before you go, we're not going to go to part 3, but I want to take a look at kind of what the weather maps look like today. I guess, yeah, these are the water cycle questions are kind of part 1 then, I guess. I guess we'll just go ahead and call it a day. And then what I'll start out with on Monday, hopefully everything will be finally scheduled. So Monday, we'll start out looking at some weather maps. But on Canvas, I did go and put some of my 3 favorite online weather websites. So that's it. Yay. Yes, ma'am. Yep. I don't think I said, but it is. They're always due the next lecture period. My point is, I hope we meet Monday. Ah, it got me confused.
We don't have class next Friday.
Correct. A week from today. It's like a teacher's in-service day. If you know, for K through 12 teachers, usually they don't go there in-service days either. Yep, but we have